Hello everybody. So we've looked previously at how fire control and range finding works in general. We've looked specifically at the plotting equipment, the fire control computers, down in the bowels of an Iowa-class battleship, specifically, of course, the USS New Jersey. And we've looked at why you might miss when you think you have a lock on and you've maybe scored a hit or two. But one thing we haven't done in our quest to look around fire control systems is actually go up to the front line to look at the systems that are actually taking the range data, the bearing data, and all the other kinds of data that are then fed into the fire control systems. And of course, it's the quality of the data from these systems that determines how accurate a solution the fire control computer can plot. So today, we're going to go and take a look at two of the systems in question, and we're back aboard USS New Jersey for this. We're going up to Spot 1, which would be the primary range-finding station in normal situations, and then we're also going to go down into the conning tower, which would be a backup position in case Spot 1 was, for whatever reason, ineffective and they needed to aim in a frontal arc, since of course there's a duplicate position aft. And so in company with Dr. John Scholes, who knows virtually everything there is to know about US fire control systems, and after a lot of climbing, we find ourselves at almost the highest point on the ship, up in Spot 1.
Today we are up in Spot 1, 116 feet above the waterline, and in the Mark 38 director, the eyes and data acquisition unit for the Mark 38 gunfire control system. I am sitting right now in one of three operators' positions that are forward of the rangefinder that occupies the middle portion of this rangefinder and director unit. The optical rangefinder is 26.5 feet long, and it's a stereoscopic rangefinder, and it's what you see projecting out of the arms or ears of this director when you look at it from the outside. I am sitting right now in the pointer or leveler's position. As you see here, there are a number of hand wheels and a telescope, and when a target was obtained by control and by the Combat Information Center and by the plotting room, the bearing of that would be transmitted to the director officer, who's actually standing behind me in the after portion of the director. He could then verbally indicate the bearing, and I would turn, the trainer would turn his hand wheels, and we'll look at the trainer's position in a second, and bring the director on target. At that point, I would be looking through my telescope, and if we were on target, I would align the crosshairs at the water line of the target, which is also the horizon, and choose a position usually approximately at the water line where the fire control tower forward on the enemy battleship target would be. I would then continue to move the hand wheels to maintain that, which would be sending a signal down to the Mark 8 rangekeeper in the plotting room that I was leveling. There are a number of other ways that I could level if I was not able to see this. The stable vertical in the plotting room could send up a signal on these dials, and I would simply match the pointer, maintaining the director level at that point. Of course, it is important to maintain the level of the director in order to get an accurate bearing on the target. There are also other controls for opening the armored shutters that normally are closed to protect the optics, and ventilation motors, etc. The pointer is one of the persons in this director who can fire the main battery guns, and he has a firing key, which my right hand is on right now, and a trigger at this point if you were going to be using selected level or pointer fire from the director. Now, the director is 116 feet above the water line, and the reference point is actually in that central periscope director in the top level of the conning tower, so there is a vertical distance between them, and that has to be corrected for parallax. And so there is an instrument here, so I can set the range, which will be transmitted actually on a series of dials, which we'll see in the trainer station. And based on that, that would match up the vertical parallax close enough that then the Mark 8 range keeper could, when it's shifted over into automatic mode, automatically maintain the vertical parallax at the correct value for whatever range the target was located at. We are also so far above the water line that when we look down at a target, depending on the range, there is an angle, down angle, and that also has to be corrected for. That's part of the vertical parallax system. Now I'll move over to the cross leveler's position. Now I am sitting in the cross leveler's position, and this is the center position of the three forward operators in the forward portion of the Mark 38 director. I have a telescope, and this telescope can be switched from one side to the other and look 90 degrees either to the left or to the right. And this maintains cross level 90 degrees across the level of sight. Again, I would look through the telescope, put my crosshairs exactly on the visible horizon, and move my hand wheels to maintain that. When I had it maintained, I would then squeeze this trigger on my left hand, which would send a signal down to the plotting room that I was maintaining cross level. If I could not see the horizon or it wasn't clear, I could get a signal from the stable vertical down in the plotting room and follow the pointer to maintain cross level. Also, if we were firing in the selected cross level mode, in other words, when the cross leveler's optical sights came on the position that we wanted to fire at, in my right hand there is a firing key, and I could also fire the guns from the director here. I'll now move over to the most important of the three operators in the forward portion, the trainer's position. I'm now sitting at the trainer's station of the Mark 38 director. I have an optical telescope, but if you'll notice, it's connected to this device, which actually is connected through shafting to the motor that stabilizes the rangefinder. This basically stabilizes this telescope in the line of sight and makes sure that I can maintain level on the target as I'm tracking it. Again, upon an order, I could either turn my wheels to match a target bearing that was transmitted from the Combat Information Center or from the plotting room or from control, or the director officer could be looking through his periscope, telescope, train it on the target that he wants to do, read off the bearing, and tell me to train left or right, in order to match the bearing that he sees the target. When I see the target in my sight and I'm aligned on it, I then call out the words target to let him know that I'm on target. And although they're missing, there's a key here which I would then squeeze the trigger of to send a signal down to the plotting room that I was now on the target, and then I would say tracking. And I would continue to follow the bearing of that target, keeping the crosshairs where they're supposed to be. That would send all that information down to plot. The Mark 8 rangekeeper would start computing a solution. When that happened, there is a light up there that would come on to tell me that they have a solution. At that point, I would switch to following the pointer that the computer says, and I would be looking through my sights here, and upon given the order of match bearings and switch to automatic, I would then flip a switch, which would then put the mode into automatic. And now, instead of the hand wheels tracking the target and rotating the director, this would all be done through a receiver regulating mechanism that I'm actually sitting on here. And the computer would be training the director. I would still continue to follow, looking through my telescope, and if the crosshairs did not maintain exactly on position watered on the target, if they started to drift either ahead or behind, I would then turn my hand wheels to make a correction. That would send a correction signal down to the rangekeeper in the plotting room, and the solution would be corrected. I would continue to watch, and once we would have basically know we have the correct solution. Now, what would happen if I could not see the target? This was night or optical conditions were poor. Well, over here behind me, I have a Mark 13 radar scope, and this is the same type of gated radar scope that is in the plotting room, and the director officer also has one of these scopes. So I could look through here and turn my hand wheels until the target was in the exact center of the gate, and then I would continue to follow on the radar scope even though I could not see the target. I could also make the same correction if the fire control system was in the automatic mode. If I saw the target start drifting off the center point, I could make corrections with my hand wheels to bring it back onto the center point, and that would send the same message down to the plotting room and the Mark 8 rangekeeper to correct its solution. So essentially, it almost does not matter whether it's day or night. The tracking system is the same. It's just whether you use optical or you use range finding. In addition, there are, again, blower motors. There's things to open the shutters or the trainer's position. And there is also one other piece of equipment which is behind here, is that we are, of course, at a different position along the length of the ship than the central reference point in the center of the conning tower at the periscope telescope. So we have to correct for that for range. So there is actually another person who sits in the after compartment who acts like a sight setter and sets the range to the target on the horizontal parallax corrector. He also matches pointer dials, and in the same way that the pointer, the cross level, and the trainer match dials to switch to automatic, he does the same thing. After that, the Mark 8 rangekeeper continually corrects the horizontal parallax. If you imagine the triangulation that we're using for solving the fire control solution, if the target is very close, the angle between this director and the reference point is quite large. If the target is very long way away, the angle between this director and the reference point is very, very small, but it has to be corrected for. And this mechanism does that automatically and continuously. We are now in the after portion of the Mark 38 Director, behind the 26.5-foot stereoscopic rangefinder, which rests on this giant thick steel arm I-beam in order to maintain rigidity, which is required for the accuracy of the rangefinder. Normally, there would be 3 people approximately in this position. One would be the operator for the horizontal parallax, who also functions as a talker. There would be the rangefinder operator, who would actually be standing a little bit forward with me, but there's an open hatch right now, and he would be standing on that hatch, which would normally be closed in battle. He would be looking through his eyepieces, and since he's a person selected to have perfect equal stereoscopic vision in both eyes, he would use the stereoscopic rangefinder to find the range. There's another person who would be standing approximately where I am, would be reading off this dial the range reading. Now that is automatically transmitted down to the plotting room, but if that automatic transmission were to fail, then the reserve rangekeeper, who by the way also can be swapped with the rangefinder operator back and forth when they get tired, would also function as a talker and could send that information down by voice. In addition, there was a radio operator originally over in this position. When radar was added and became more and more important, for a while, radar components were actually up here in the director. They needed to be close to the antenna because waveguide transmission was not very good in the early parts of World War II. Once waveguide transmission became much more efficient, all of that equipment was moved down to the main scope, which we've seen in the main battery plotting room, and only the portions of the system that have the scope that indicates the gated position of the target and used for spotting of shell splashes were up here. So that relieved slightly more room in the director, but not much. Reaching forward here, you'll notice this handle. Now, this optical rangefinder is normally stabilized in level and cross level by a power drive, and the cross level is done by rotating the prisms. This can be fed either from the pointer or leveler, and cross levelers positions optically directly from this director, or it can be fed up from the stable vertical in the main battery plotting room and automatically transmitted to the range to keep it on target in level. If, however, all of that mechanism fails, then this handle can be pushed up and down, and you can manually rock this rangefinder to keep it level enough so that you can make a range reading. We are now in the after portion of the Mark 38 Director, and we are looking at the back wall of the Director. In this area, there are basically a number of units concerned with communication and control. There is switches to select various circuits on the sound-powered phone network so that the director can communicate with control, with the plotting room, with the combat information center, etc. They're also selecting power supplies and selecting the setup for the director, selecting whether or not, for example, the Mark 41 stable vertical down in the plotting room might be doing all the stabilization and leveling and cross-leveling for both the director and for the optical range finders. It also allows the spotting officer, whose position we'll see next to have communication verbally with all of these other stations. I'm now standing in the last operator's position. This is the spotter, who's also the director control officer in the Mark 38 director. My right hand is on a periscope that projects through the roof of the director and can be trained in 360 degrees. This is used to acquire the target and also to spot gunfire relative to the target optically. If, for example, the director control officer acquires the target and wants to designate it to the director, he would acquire it in his periscope. He would then transmit the bearing to the trainer, who would bring it on to the target. The leveler and cross leveler would then make sure that they have their crosshairs properly aligned with the horizon in both level and cross level, and then the director could send all that information down to the computer, or if the main battery plotting room was knocked out and the rangekeeper was not operative, this could actually be sent directly to the turrets, and then they could calculate their own solution from the information being provided by this director, and the guns could be fired either from the director itself or they could be fired from down in the turrets, depending on what was selected. All of the communications equipment that you just saw on the back panel is mostly here for the spotter to be able to communicate with the rest of the fire control system. He normally has a sound-powered phone headset on and does that directly, but if that fails, the reserve rangefinder operator is also a talker, as is the horizontal parallax corrector, and either of them can transmit his information down to the rest of the fire control circuit. Now, if the spotting officer is not able to see the target optically, or if conditions are not ideal, behind me there is another one of the gated Mark 13 radar scopes. And again, this would normally be positioned by the trainer and the director, who would be keeping the target in the center of the field. But when the salvo arrives, splashes that are 300 or 400 feet high occur as the shells hit the water, and those splashes are visible on the scope, and their relationship to the target is also visible on the scope, so that one can make spotting corrections. The Mark 13 radar was so good that one could spot individual shell splashes, and therefore you could count the number of shell splashes versus the number of shells that you fired in a salvo. If the number of shell splashes was less than the number of shells that you fired in the salvo, you knew how many hits that you got. This gave terrific advantages in spotting in range, because that's very difficult to do optically, but the radar makes it almost easy. Now, you may have been noticed how crowded everything is in the Mark 38 director. Well, there's a reason for that. All of this equipment is protected by an armored shield, which is 1.5 inches of STS, special treatment steel armor. And this director, with the Mark 13 radar antenna, which sits on top of the director about 6 feet higher than the optical line of sight, weighs approximately 50,000 pounds, or over 20 tons. Now remember, we're 116 feet above the water line, so you can imagine the effect that every pound up here has on the stability even of a huge ship like the battleship New Jersey or the other fast battleships. So it's important to minimize the dimensions of this armor box and the weight of all the components in order to help preserve the ship's stability.
Luckily, neither myself nor Dr. Scholes suffer from claustrophobia, But we are not immune to heat, and since we filmed this while the ship was in dry dock, and therefore had very limited shore power, there was no air conditioning up there in Spot 1, so by the time we finished, it was a little warm. So we were very grateful to get out of there and head down to the comparatively roomy confines of the ship's conning tower, which is where we'll pick up the narrative.
We are now standing in the upper level of the conning tower of Battleship New Jersey, and we are in the last of the director positions on board this ship. Spot 1, of course, is the Mark 38 director at the top of the fire control tower forward. Spot 2 is the Mark 38 director at the top of the aft fire control tower. And this is Spot 3, which is a Mark 40 periscope director located in the top level of the conning tower. In the original World War II design, this was the main battle station of the ship's main gunnery officer, who controlled basically all of the ship's gunnery equipment, and all control was directed through him. This, however, in terms of its use as a director, was actually considered an auxiliary or backup mode if Spot 1, Spot 2, or the range keepers in the main battery plotting rooms went down. This has the ability to track in bearing a target optically, but does not have direct attachment to the fire control radars in order to track it and range on it with radar. There are basically 4 operator positions here and 3 periscopes projecting through the roof of the turret. In addition, there are tubes from 2 additional periscopes that are located in the next level down of the conning tower that project through its roof and then through the roof of this level of the conning tower. Let's first start looking at the most important periscope, the one in the center of the director, which is where the trainer and the spotter, who is also the ship's gunnery officer, stand. I'm now standing at the trainer's position. His hand wheels will rotate the periscope in front of me, and he can optically line up his crosshairs on the waterline of the target. Now, in order to compensate for the ship's rolling and pitching motions, this periscope and director system is mechanically geared to a level and cross-level periscope, one on the right side and one on the left side. Either one of those periscopes can perform either the level or the cross-level function. If one is performing the leveling function, then the other is switched 90 degrees in rotation to perform the cross-level function. If the view from either the leveling periscopes is blocked, it then can reverse and become the cross-leveling scope, and the cross-leveling scope can become the leveling scope. So it's a very versatile system. There is also on this particular periscope the ability to transmit bearing and tracking information down to the main battery plotting rooms so that that information can be run through the Mark 8 rangekeeper, and the level and cross-level information can also be sent to all the other components of the system, including the turrets and the plotting room, to substitute if the stable verticals in the plotting room are not operative, or if optical conditions are considered so optimal that it's better done here than down at the automatic stable verticals. Now, this periscope has a mirror system in it so that its image is also transmitted to the other side And I'm now going to move around to the position of the spotter. And you'll see that there is another periscope here. This is where the gunnery officer would sit. Originally, when this was first built for the fast battleships, this periscope was connected to a spotting scope, basically, which looks like a stereoscopic rangefinder and actually has a stereo viewing function, but does not actually function as a rangefinder because it does not have a range transmission unit in it. It is used to spot the target and then spot shell splashes and see how far from the target they are. This works very well if the shell splashes are to the right or left of the target. In other words, they miss in deflection. And there's a graded scale where you can measure that off to get the exact distance that they fall. However, it is very difficult to spot how short or how long splashes are. Splashes behind the target oftentimes cannot even be seen where they hit the water, so they are very difficult to tell how far they are long from the target. And even the ones that fall in front, where you can see exactly where the shell hits the water, you still have to use a stereo vision estimation of where that is, and most people found that fairly challenging to do. Once radar was available, that provided a much better view when you had precision radar, and you could actually see on a scope as if you were looking down like a bird at where the shell splashes were. Much, much better for determining spotting by range. This, of course, is being trained, and because it's connected to the leveling and cross-level periscopes, this is kept on level, so the spotter is having a continual view of the target through this. Now, in the other fast battleships of the North Carolina and South Dakota class, this director unit, in addition to sending electrical signals down to the plotting rooms, also had a mechanical shafting, and there was an auxiliary fire control computer known as a Mark III sitting about here, which was mechanically geared to this. So this could take over the entire fire control problem in case of an emergency with the plotting rooms being knocked out. Remember that the North Carolina and South Dakota classes have only one main battery plotting room. If it was so unfortunate as to be knocked out by battle damage, this would have to take over the whole fire control solution. The Iowa class, however, have separate forward and after main battery plotting rooms, giving much better protection by redundancy, and therefore this station did not really need to take over the whole fire control problem, and therefore it did not need its auxiliary computer, and this opened up a great deal more space in this room for other equipment such as radar. Now, on the North Carolina and South Dakota classes, and originally on the Iowa class, there was a radar that actually was on the top roof of this level of the conning tower. It was a Mark 27 radar, which originally was a range-only radar. It would only give you range to the target. This could substitute in part for an optical rangefinder, which this station does not have. However, during World War II, some very clever radar men figured out how to rewire the Mark 27 radar so it would produce information both for range and for bearing, and would actually give you a B-scope or plan position indicator, the typical radar sweep scope that we all think of. Radar was actually be able to be produced by the Mark 27. This made it a great deal more useful. Even though its bearing readings weren't really accurate enough for full radar control of gunnery and bearing, it did give range, and there were some additional functions that it could do. It could function as a backup navigation or surface search radar now that it had this B-scope presentation. So that made the Mark 27 auxiliary fire control radar here much more useful. Now, as you remember, this station was intended to be the primary battle station of the ship's main gunnery officer. The Mark 27 auxiliary radar provided some radar information, but it really was not optimal. So that was removed later on in the Iowa's career, and instead, scopes for the Mark 13 fire control radars were installed here, one for the forward radar and one for the aft radar. Again, these are the same gated scopes that we've seen in multiple areas of the fire control system, putting the target in the center so it can be tracked there, and also allowing you a view or window of all of the shell splashes around the target. This is actually the information that probably was most valuable to the ship's gunnery officer in terms of spotting, better even than he could do optically, especially in the range function. Okay, on the back portion of the upper level of the conning tower are control and communications information. There are telephones to the ship's main circuit. There are multiple jacks for sound-powered telephones because this position is on the main battle circuits. It's also on the main fire control circuits. So it needs to have a lot of communication with other stations at the ship. It also needs to communicate with the turrets, and the turrets need to communicate back with it. And we have the set of turret ready lights up here. Each one of these has a lamp showing whether the turret is not ready or whether it is ready. And depending on what type of salvo pattern or firing pattern you're going to use, you're going to be looking for whether all 3 turrets are ready or whether only selected turrets are ready and able to fire. There are also the ability to fire the guns from here from both the levelers and cross levelers position, and they also could be fired by the ship's main gunnery officer at his spotting position if he wanted to. Moving over further, again, we have turret train indicators here. We also have information on the ship's secondary battery directors and where they're trained. We have a gyro compass showing the ship's course, and we have multiple rotary switches to set up various fire control positions, kind of an auxiliary switchboard, and also many of these are also rotary switches for all the communications circuits here. I'm now standing at the left-hand level or cross-level stabilization periscope that is mechanically linked to the primary training and control periscope. I have again a set of hand wheels here, and I'm looking through my eyepiece. If I'm doing leveling, my crosshairs vertically should be on the center of the target, and my horizontal crosshair should be exactly on the water line of that target, which is the same thing as the horizon. If I'm the cross leveler, I should be looking at the horizon and keeping my crosshairs exactly on the horizon. I have 2 triggers here. One trigger is to signal to the transmitter of this scope, which is transmitting that bearing information, that I am at level, and therefore the information that's being transmitted is correct. The other is a firing key in case we were going to use selected level to fire the ship, and I would be turning my hand wheels, and when I was exactly in the right position, I would then squeeze this trigger, and if the circuit was rigged up in that manner, that would fire the guns. The right-hand periscope is essentially identical and can perform exactly the same function. If this one was set for level, that one would be set for cross level, but they could be switched at any time upon direction of the gunnery officer. Now, the conning tower, as you might remember, is an armored cylinder with walls up to 17 inches thick. And how do you see out of it? Well, not very well. There are slits cut in it, which you see here. Notice the tremendous thickness of the armor. This, however, does not give you much of a view, and you have to move around to each slit to see even a small window. Because of this limitation in vision, many commanding officers did not like to use the level below as their main battle station because they could not see very much. And even some gunnery officers did not prefer this, and they preferred to be in other positions because they would have a better view, or some of them like to be in the main battery plotting rooms so that they would be able to see all the information going into the rangekeeper and have the most information about the gunnery situation.
Unfortunately or unfortunately, that was not the approach of the world's most obvious Terminator. That was, in fact, the crane operator signaling that if we wanted off the ship, that was our time to leave. And so we're going to wrap up there. You've now seen a bit more of what's involved at the sharp end of the stick when it comes to actually spotting the enemy, locking onto them, tracking them, and supplying all that data down to the fire control computers so that the big guns can do their business. Hope you've enjoyed that, and see you again in another video.
That's it for this video. Thanks for watching. If you have a comment or suggestion for a ship to review, let us know in the comments below. Don't forget to comment on the pinned post for dry dock questions.
And then I'm going to try and get out of the way. Okay, whenever you're ready. That's not good. Okay.
Control and communication circuits. There is links to sound-powered phone. Did we lose our...
Yeah, that's dead.
Nope. Okay, well, hopefully we've got enough to finish here.
Yeah, we've got enough light.
Okay, let me start over again here.
Is that okay? Not in your eyes?
Yeah, that's good. I can use the periscope here to keep it out of my eye.
In that case, I'm going to do down this way. And now I'm out of shot, so all yours.